Hello guys, this is Paul McWhorter from TopTechBoy.com, and I am here today with lesson number 3 in our improved, our exciting series on working with the Arduino. If you haven't done it already, you need to order your eLego Super Starter Kit from the link below. Hook a brother up in the description. There's a link. Help me out a little bit. Order your kit, and you will be able to play along at home as I go through a lot of exciting projects using this kit. The other thing I need you to do, if you haven't done it already, pour yourself a nice mug of iced coffee. Yes, and then you can play along with us at home. You guys, in the old series, I did hot coffee. This is summertime here in West Texas, and so I will be, for this series of lessons, be drinking iced coffee. I hope you will do the same. Okay, in lesson number 1, we did a very simple program. You wrote your first program for the Arduino where you could make this LED blink, and you could control the timing and characteristics of how the blink occurred. Then, in lesson number 2, we talked about how an LED works, sort of the physics behind the LED. If you haven't worked on lesson number 2, go back and watch it, because I don't want you to think about microcontrollers or Raspberry Pis or Arduinos as things that you just type commands into. I want you to start understanding what's going on, the magic that is really going on down in the silicon that these chips are made out of. So watch that lesson so you know what's going on. Today what we're going to do is we're going to move forward and start looking at how to hook up external circuits, because one of the really amazing things about the let me move out of your way before I go on. One of the amazing things about the Arduino is that you have all of these pins, and then you can write programs that will send signals to these pins or read signals from the pins. And so as you hook these pins up to things like LEDs or sensors or GPSs or other components, that's where the magic happens. This is like a computer where you can interact with the external world through sensors and actuators and GPSs and things like that. So the trick, though, is that we've now got to learn how to connect things up. How do we go about connecting these pins to things that will work in the work with and interact with the external world? Well, one of the things would be that you always end up with, and let me zoom out so that you can see this better, you end up with something like this, which is a circuit diagram. This is what you want to do. And this is what we talked a little bit about in lesson number 2, how to make an LED work. This is the LED. You apply a voltage to the LED, but you need a current limiting resistor in series with the LEDs so the LED doesn't get too much current and burn out. And then this is kind of the ground hooked to the negative of the power supply. So this is a schematic, or this is a circuit diagram. How do we turn this into something that is working with the Arduino? Well, good news is, if you have ordered your kits, you have everything that you need in order to start building circuits. And what you don't want to do in building circuits is you don't want to like get your LED and try to twist it together with the resistor and then come over and plug it in and just try to kind of hook things together by twisting leads together. You want to have a neat and organized way to hook things together. And luckily, your kit has just the thing for that. And let's see if I can put this kit over here. Ooh, microphone disaster. Okay, let's zoom out a little bit so you can open your kit up. And if you look in this top section, hidden down in here is the prototyping board, okay, the PC board or breadboard or prototyping board. And so what we're going to do today is we're going to learn how to use this prototyping board in order to actually build a circuit. And this is kind of lets you go from a circuit diagram down to something that will actually work. So we're going to take this and we're going to open it up and we're going to pull it out. And then this is the board onto which you will build your circuit. So we're going to start hooking things up from the Arduino to components that are going to be plugged into the board. But the challenge is, how do we go from this picture into things on this board? How does this board work? All right. That's what we're going to do today. So what we're going to do is we're going to learn how the board works, and then we're going to get a resistor, and we're going to get an LED in our Arduino, and we're going to hook the whole thing up. But step one is you have to understand how the board works. Like, what is the mentality, or what is the algorithm behind how this board is laid out? And then you will understand how to hook things together. And so we will come over here to this background, and this is kind of the key to understanding how to hook things up on the board. And so let's go back, and I'm sorry, I'm trying to kind of get you rolling with this, but let's go back and let's look at this. I lost my mouse. Okay, let's go back and let's look at this circuit. So you see that you're going to want to take the voltage, which will be the positive voltage, which we could have, like, right, if we connect it to pin 13, we could get the voltage from pin 13. So pin 13 needs to go to one leg of a resistor. The other leg of that resistor needs to connect to the long leg of the LED, right? The long leg of the LED needs to be pointed towards the positive voltage. And then the other leg of the LED, the short leg of the LED, needs to come back to ground, or the negative. And you can see that there's a ground pin right next to pin 13. So if we have pin 13 go to resistor, the other resistor go to the long leg of the LED, then the short leg of the LED coming back to the ground pin, we could build this. But we need to build it on this circuit board. Well, how does that work? Well, let's look at the circuit board, and this is the thing that you have to understand, is looking at the board here. The thing to understand is the columns, these little holes in the breadboard, the columns are connected together. The holes along the columns are connected together. So if I brought one leg of the resistor into this column and one leg of the LED into this column, those two legs would be connected together, okay, except for across this center region. So let's go back and look at the actual board. Do you see you have this kind of dividing layer? All of these holes are connected together in a column. All of these holes in a column are connected together, but those two columns are not connected across this little divot. That is a channel. Okay, so let's go back and look here. And I'm sorry if I'm repeating, but you really got to understand this. And I have a lot of students that I teach, and I just see it takes a little while to understand this. So these holes are connected together. Anything that is plugged into these holes will be connected together. These holes in this column are connected together, okay? But this is not connected to this. The red is not connected to the blue. Similarly, as you go across a row over here, as you go across a row, I hope you can see my mouse, but the little green row, those holes along the rows are not connected together. And if you jump over this center channel, those are not connected together. So column is connected on the top, column is connected on the bottom, holes along a row not connected, and holes across this channel are not connected. But we do have some special rows. These rows across the top are all connected together. This row across the top is connected, but this row is not connected to this row. So first row, all connected. Second row, all connected. First row, not connected to second row. Similarly on the bottom, the entire bottom row is all connected, and the second to the bottom row is all connected. And you can see that on the live shot here. Let me see if I can zoom in. Okay, so you see on your board, if you connect anything all the way along there it's connected, or all the way along there it is connected, but that row is not connected to that row. So what is this for? Well, a lot of times you might need a lot more than just the 1 or 2 ground pins, like you see the ground pin on the Arduino. What if you needed a lot of grounds? Well, you could run a wire from the ground pin on the Arduino and then hook it up to this negative row, and now all across this entire row that is labeled negative, that's going to be a ground. Or if you wanted to bring 5 volts, you can see that the Arduino has a 5 volt output. If I can show it, yeah, you see that 5 volt output? You can take that 5 volt output and then you can connect it to the plus row, and then they're all connected together. Okay, so you see the board is a way to plug components in and get nice secure connections that allow you to build this circuit. Man, because students struggle with this, I'm going to go over this one more time. Okay. Holes along a column, like you see in this red column, they're connected. Holes along the column on the bottom, they're connected. The 2 columns are not connected together. Rows in general are not connected, except for the top row is all connected. The second row is all connected. The second to the bottom row is all connected, and the bottom is all connected. So this will allow us to hook up a circuit. So now what we need to do is we need to go to our Arduino kit, and we need to find some things. Well, what do we need to find? Let's go back and look at our circuit. We need to find a 330 ohm resistor. If you don't have this kit, anything in that range will be okay. A couple of hundred ohms, probably 200 to 500 or 600 ohms would work. You need to find that. And then we need to get an LED, and then we need to get some wires. And so let's look in our kit and let's see if we can find some of this stuff. We got our PC board, we got our Arduino. Let's see if we can find some other components that we need for this project. And so if I look here, I find this envelope which has resistors in it. Okay, what you have to see is these resistors have different values, and what you've got to do is you've got to pick the one that you want. And you can see this one set of resistors has a label on it to help you out. We can talk on another day. You can actually figure out what the values are by looking at these color codes. But today we're going to cheat and just see that these are the 330 ohm resistors. You can see that your kit also has some like 1K resistors. I see 1K, I see 5K, I see 10 ohms, I see 100K. You got a lot of different resistors here, but what do we want? We go back and we look at our circuit, and we see that we want a 330 ohm resistor. And so I will take this and I will carefully pull off a individual resistor. Don't bend these up, keep them nice, and then put the other ones back in. Okay, and then put your little envelope back in down here. Okay, boom. You now have this resistor that you need. What do I need now? I need an LED. So we come, and my LEDs are right here in this little packet, and we are going to use a red LED. Okay, red LED. So now, I've got my red LED, I've got my current limiting resistor, and now I just need a few wires to hook this thing up. And so your eLego kit has got a generous assortment of these wires. So let's see if we can figure out how to hook this thing up. Let me see if I can kind of get this and this all together. Yeah, I want to kind of try to lay it out physically like what it is going to be on the circuit diagram. Okay, so let's try to do it like this. All right, where do we start? Well, we start with the positive supply voltage. Where are we going to get our voltage from? Remember from lesson 1, we're going to get our voltage from pin 13, so we can control pin 13. So I need to get a wire, and my goodness, it looks like they've got these things in with a zip tie. And do I have a knife? Yes, I have a knife. Actually, what I would recommend that you do is, I don't have one handy, I would recommend that you get a rubber band and try to keep all these things together so that you can keep your kit neat. Wouldn't it be funny if I like sliced an artery right here on YouTube and started bleeding profusely? Okay, so I have an individual wire. So let's look on this circuit diagram. I want to go from the positive voltage, which we're going to get from pin 13. So I'm going to plug that wire into pin 13. And you've got to really pay attention because it's very easy to be off by one. So I've got the wire into pin 13. And then I am going to come over here to just a random column. Okay, I'm going to just connect it to a random column. And then what do I want to connect to? I want to connect to one leg of the resistor. What I like to do is try to keep things neat. So I try to kind of make my resistors look like this so I can keep them neat. Now, I want that voltage to be connected to the resistor. So what do? Do I put them in the same row? No, if I put them in the same row, they are not connected. They need to be in the same what? They need to be in the same column. So I'm going to come and I'm going to put this resistor in the same column . Okay. Do you see that this resistor has one leg that is in the same column with this wire that is coming from the 13 volts? Okay, so let's back off a little bit so you can see the whole thing. Now, what do I need to do? I need to connect to my LED. So the other leg, the second leg of the resistor, first leg of the resistor, second leg of the resistor needs to connect to what? The LED. Did you watch lesson number 2? What's very important about an LED, the direction matters. And it's the long leg. The long leg needs to go towards the positive voltage. So here's the positive voltage. So the long leg needs to go to the second leg of the resistor. So long leg, look how we're doing this. Let me see if I can zoom in again. This is going to get annoying, I think, to you after a while, but that long leg needs to connect to the second leg of the resistor. So what does that mean? It needs to be the same column. Okay, so let's see if you can see this. Let me kind of make it like that. I really want you to see this. Okay, long leg of the LED is in the same column as the resistor. So now this is connected to this. Long leg of the LED is connected to the resistor. The other leg of the resistor is in the same column as this wire, and then that wire is connected to pin 13 of the Arduino. All right, so now let's back off and let's see how we've connected this. And if you already have this figured out, I'm sorry that I'm boring you, but I just see the first time students do this, a lot of times it's really confusing because this is an abstract schematic of the circuit and you have to turn it into a physical connection. So we've got the positive from the Arduino pin 13 going to the one leg of the resistor. Then the other leg of the resistor goes to the long leg of the LED. Are we done? No. The short leg of the LED right here needs to come back and connect to negative, which is ground. Where do we get ground? Oh my, let's look at the Arduino. I'll try to zoom back in. And do you see the G and D? It's right by pin 13, that G and D. right there by pin 13. Got to put it in carefully. Okay, got to put it in carefully. Okay, so you see the red wire is in pin 13, and now the G and D wire is coming here to this. Okay. Now, before I hook this up, we need to go back and write our program. Okay, we need to go back and write our program. So let's see if I can switch back over here. Let's fire up our Arduino environment. And this will just be good review, so you guys should already know how to do this. Okay, and I am going to go to a slightly different view here so you can see the physical circuit with the Arduino and the breadboard. You can see that at the same time that you see the code that we're working on. Okay, so what do we do to start a sketch? This is review from earlier. We're going to go to examples, we're going to go to basics, and we're going to go to bare minimum. Okay, every Arduino program has two things. It's got the void setup, which starts with the curly bracket, ends with a curly bracket, and the void loop starts with a curly bracket, ends with a curly bracket. Okay, so what do we do in the setup? We do things that we want to do one time. What do we want to do one time? Well, if we're going to work with pin 13, we have to do the pin mode. We have to tell it that we're working with pin 13. So how do we do a pin mode? We go PIN capital MODE, turns orange, happy little color saying it recognizes that, that command. If you did not type it in right, it would not turn orange. Okay, what pin are we going to work with? 13. And 13 is going to be a what? Output, all capitals. All right. Every line in Arduino, almost every command ends with a colon. We have now set this up to tell it that we're working with pin 13. Pin 13 is an output. That's what we're going to do once. What do we want to do over and over? We want to turn the LED on and then turn it off. So how do we do that? We do a digital write, capital W, everything else lowercase, turned orange means it recognizes the command. We got to give it the parameters, so we open the parentheses. What's the parameter? We got to tell it what pin we're connecting to. What pin are we connecting to? 13. Now we got to tell it, are you going to turn it high, which is on, or are you going to turn it low, which is off? Well, we want to turn it on, so we're going to say high. Okay? Now, almost every command in Arduino ends with a semicolon. Now what do we want to do? Well, we want to leave it on for a while, so we do a delay. So we set for how many milliseconds, one parameter for the delay command, and it is in milliseconds. We are going to put 500 milliseconds. 5,000 milliseconds in a second, so 500 milliseconds is a half a second. Almost every command ends with a semicolon. So we turn the LED on, we wait half a second, then we're going to turn it off. So digital write, what are the parameters? Well, we're still talking to pin 13. And now we turn it low, L-O-W. Typed it correctly. Okay. End with a semicolon. Now what do we want to do? Well, we want to leave it off for half a second, so we say delay, and then 500. Okay, and then we end with a semicolon. All right, now what we are going to do is we are going to download that into the Arduino. So we come up and we get this little right mouse arrow, right arrow. We see the happy little green bar. Okay, and now it is all hooked up. Remember, just make sure that you're on the right port. You can see if you come to Tools, Port, that you can see that my Arduino is on COM3. Yours should say Arduino, but it might not be COM3. You pick whichever COM has the Arduino by it. And then make sure you're doing the right board. We're doing an Uno, so we set it here for Uno. With that stuff, it should work. And so now we've downloaded the program. Let me come back over here and let's just look at this circuit. So you can see that on our circuit, we now have the program in the Arduino, and we have everything on the circuit except for we have not made the connection from the short leg of the LED back to the negative, which is the ground. And so we need to take this, which goes to the ground, right? It goes to the ground on the Arduino, and we need to connect it to this short leg. And so look, boom, what is happening? Boom, the LED is blinking. We have built our first circuit, and that circuit is controlled by the Arduino, which is controlled by the program that you wrote. So let's come back over here. Let's blink differently again, okay? Let's do something a little more exciting. Let's jazz it up a little bit. Let's go 50 milliseconds on, 50 milliseconds off. This is going to be blinking really fast. In fact, I don't even know if you'll be able to see this over here. Okay, we downloaded it, and look at that. Blink, it's going really, really fast. So now you can control this LED by, you can control the LED by the program that you're writing. Does that make sense? You change the program, and you're able to control how this blinks. Okay, guys, we have done some really neat stuff today. Let me play around. Let me just do something else, okay? All right, so let's look over here. Let's look over here. Where am I? Where am I? Let's go to this one. Okay. Do I have to use pin 13? No. I can use anything from pin 2 all the way to 13. 0 and 1, those are used for communication, so you don't want to use that. Let's use a different pin instead of pin 9. Let's take our red wire out of pin 13, and let's put it on pin 8. Let me put it on pin 8. I missed it by 1, so always check this carefully. Okay, so now I'm on pin 8. I'm on pin 8 instead of pin 13. When I plug it into pin 8, it doesn't work anymore. The LED isn't blinking. Why? Because on the program, I told it that I am working with pin 13. So if I want to make it work with pin 8, which I'm connected to now, over here, I've got to do the pin mode now for what? Pin 8. Now, would I still write digital write 13 high? No. I'm going to write digital write pin 8 high and digital write pin 8 low. Now, what do I do? Okay. Be watching this LED as I download the program now. I'm reprogramming it to use pin 8. And look at that. Now it's working with pin 8. Okay, so you have learned how to use the breadboard. You have learned that you need to use a current limiting resistor. You have now written a program where the Arduino you're writing a program in Arduino which is controlling an external circuit. This is huge because an LED isn't that exciting, but you could put exciting things on here. And instead of controlling an LED, you could be controlling a GPS or a servo or all types of different things. So this is really huge that we can do this. All right, I need to give you your homework for this assignment. And on your homework, what I want you to do is, instead of having one LED that you're controlling, I want you to control 3 LEDs. I want you to have a red LED, a green LED, and a blue LED. And I want you to blink the red LED 5 times, and then blink the green LED 10 times, and then blink the blue LED 15 times. Okay, so your program is going to be more complicated. Are you going to be able to do it all from pin 8? No. This time you're going to need how many pins? You're going to need 3 pins. How many pin modes? You're going to have to do a pin mode for each one of those pins. And then you're going to have to write the code here where you like go on, off, on, off, on, off on pin 8, and then you're going to have to go on, off, on, off, on, off, on, off, on, off, on, off, on the pin that you have connected. Also, each resistor is going to need its own current limiting resistor. So you're going to have a resistor and LED, a resistor and LED, a resistor and LED, and then your code is going to have to do that. I think you guys can do it. Okay, I think you guys can do it. Paul McWhorter, TopTechBoy.com. If you like this lesson, think about giving us a thumbs up. Think about sharing it. Think about actually doing the homework, because this time around I want to be giving you guys assignments where I show you a simple thing and I have you go out and do a more complicated thing. Paul McWhorter from TopTechBoy.com. I am enjoying my iced coffee, and I will talk to you guys later.